Hi, welcome to Pre-Calculus Sequences and Series. In this video, we're going to talk about sequences and series with word problems, right? So essentially, when we're talking about word problems, we're talking about context, right? We're not just giving you numbers for numbers' sake. We're giving you word problems, problems that involve sequences and series, arithmetic, geometric, that actually make sense in terms of real-world problems. So let's just get right down to it. We're going to look at several examples. I'm going to try my absolute best to make sure that they're easy for you. But again, all the formulas I'm going to use to help me here are the same formulas we've been learning for arithmetic or geometric. All right, so Jake plans to start a new running plan to train for cross country. He plans to run 2 miles the first week, then increase his running by 3.25 miles each week. How many miles will he run, not be run, will he run the 12th week of training? So sometimes I just get the ball rolling. So the first week he's going to run 2 miles. And then he's going to increase 3.25 miles each week. So every week he's going to increase. This certainly sounds arithmetic to me because we're adding 3.25 every week. So the second week he's going to add 3.25 miles. So now he's going to run 5.25 miles the second week. The third week, he's going to add another 3.25 miles. So now he's at 8.5 miles in that third week. And then the fourth week, he's going to add another 3.25 miles. So that's 11.75 miles he's going to run the fourth week. And that's going to continue. So they want me to figure out in that 12th week, how many miles will he run? So I could just kind of keep going following this format, but that might take me a while. So why don't I come up with a formula to find me how many miles in any given week? So that formula, once I recognize this is arithmetic, the formula is very easy. It's the first term, which is 2, plus what we're increasing by each week, 3.25, n minus 1. That's it, guys. And again, obviously I could clean this up by doing a little bit of cleaning up by distributing. 3.25n minus 3.25. So that's going to be 3.25n. And then again, combine the 2 minus 3.25, combine those like terms there, I get minus 1.25. So that is a super cool formula that can determine how many miles Jake is going to run any given week. So now the question is how many, I'll use a different color here, how many miles is he going to run that 12th week? Well, now all I got to do is plug in 12, and this problem becomes insanely easy. So I'm going to go to my calculator, 3.25 times 12 minus 1.25. He's going to, boy, he's getting ready for a long run here, 37.75 miles in that 12th week. So again, that's the whole week. That's not in a day or an hour, right? This is just in the entire week. So he needs to run a lot of miles that 12th week. And maybe that's going to be the last week of his plan to truly show that he has gotten really good and he's built up his stamina to run. All right, let's take a look at the next problem here. So Mikey has a large bag of, another typo there, man, lots of typos, I'm sorry. Mikey has a large bag of 190 jelly beans, and he eats 3 jelly beans per day as part of his morning routine. How many jelly beans will be remaining after 8 days? So let's see here. Let's be very careful. So after 1 day, there's going to be how many jelly beans? Now listen, 190 is where we started. That's how many were in the bag. But after 1 day, at the end of 1 day, there's now 187 jelly beans left. So after 1 day, remember that he started with 190, but after day 1, 187. After day 2, after 2 days, he's going to eat another 3, so now he's down to 185. After 3 days, 185. Boy, oh boy. At least I caught it pretty quick. 184. He's losing 3 jelly beans. After day 3, he's going to have 181 jelly beans. And again, I want to go all the way down to after 8 days. So again, I want to create a formula. So that's why kind of just getting the ball rolling is helpful. So this is clearly arithmetic. I'm losing 3 jelly beans every day. So my formula is going to be how many jelly beans were left after the first day? That's 187. Most kids are going to want to say 190 there, but be careful. Remember, after day 1, there's 187. Day 0, if you really want to get down to it, day 0 would be 190. But again, formula calls for day 1. So plus -3, he's losing 3 jelly beans every day, times n minus 1. And again, I could clean this up. Distribute the -3, I get -3n plus 3. So I get a to the n equals -3n plus 190. And this actually might make more sense. I mean, listen, because it actually makes sense. The 190 is where you start, and then you're losing 3 per day. So that formula actually makes a lot of sense. So now I want to actually go ahead and figure out, all right, after 8 days, how many jelly beans are left? Well, that's going to be -3 times 8 plus 190. So -3 times 8 is -24 plus 190. After 8 days, there'll be 166 jelly beans left in that bag. So again, a very similar problem to the one we just saw, but now we're going down, not up. But it is a little bit different because you got to think that the number they gave me, 190, is not how many is after 1 day. After 1 day, it was 187 because it was after 1 day he ate the 3 jelly beans. So again, be very careful to make sure you read the problem carefully. All right, here's another one. Kathy invests $570 into a banking account that pays 2.5% interest compounded annually. If she has no plan to deposit or withdraw money from this account, how much money will she have after 12 years? All right, so, what interest means is that she has $570. At the end of that first year, they're going to, that's how much she had initially, right? So she put in $570. And then at the end of that year, they're going to say, okay, we're going to give her, or going to add on 2.5%. So they're going to take 2.5% of 570 and add it on. So let's do a quick little lesson over just that alone, right? So we're going to take $570 and we're going to add on 2.5% of that. So we're going to take 570 multiplied by 0.025, that's the 2.5%. So this is how much she had in there already. This is how much they're going to add into there. So one way you could look at this is if both of these terms have a 570, so you could factor out that 570 and you get 1 plus 0.025. So it actually makes sense to say, listen, how much money will she have? Well, it's 570 plus 1.025. So please make sure you understand that, right? What's happening is we're starting with 570, but then again, we're going to multiply by 1.025. We're multiplying by 1 because she's keeping the $575. No one's taking that money away from her. We're going to give an extra 2.5% on top of that. So that makes, hopefully you understand that, right? That hopefully makes a lot of sense. So she have no plans to deposit money, how much money will she have after 12 years? So the first question is, okay, how much does she have after 1 year? Well, after 1 year, we're going to take that 570 and we're going to multiply it by 1.025, right? Does that make sense? Again, the 1 is there because we're keeping the money that she had. We're adding on the extra 0.025 of 570. So again, we can actually go to our calculator and calculate this. 570 times 1.025. So she now has $584.25, 25 cents in her bank account. And then after 2 years, what they're going to do is they're going to take that much money. They're going to take that much, the 584.25. And they're going to times that by 1.025 because she's then going to she keeps that money and then she's going to make the extra 0.025. So we clearly see that we're multiplying by 1.25 every single year. That makes this geometric. So what's my geometric formula? Well, it's the first term times my ratio to the n minus 1. So, sorry about that. Okay, hit the wrong button there. So when we talk about the first term, we talk about how much money she had after 1 year. So that's 584.25. 584.25. A lot of kids want to put 570 right there, but no, remember, the first term is how much is after the first year. And after the first year, we have that 570 times the 1.025. So then my ratio is 1.025, and again, raising it to the n minus 1. Okay? So that's my formula to find it, right? That hopefully makes a lot of sense. So what I needed to process was, just kind of start getting the ball rolling. So I first had to realize how much money does she have after 1 year? Well, again, that's what I kind of did over here, right? I kind of said, okay, she has $570 in the bank account, but they're going to give her 2.5% of that added on. And that's why I said, well, wait a minute, let me just factor out the 570 that's common between these two terms. And that's how I get, realistically, the easier way to think about that is She had $570. She's going to multiply that by 1.025. 1 is keeping the 570 and then adding an extra 2.5% or 0.025 as a decimal. So after 1 year, that was the 584.25. And then again, what I'm multiplying by each and every year is 1.025. And again, the formula is raised to the n minus 1. So now the question says, all right, after 12 years, how much money she's got? So all I got to do is plug in 12. So I got 584.25 times 1.025 raised to the 11. 12 minus 1 is 11. Go to my calculator here. And I have 584.25 times 1.025 raised to the 11th. So after 12 years, she will have a lot of money in her account, right? This is, well, first I have 2.5. Whoa, 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 whoa. Oh my gosh. I'm just full of mistakes today. I typed in 111. Please, oh my gosh, I thought that number was too high. There we go. So after 11 years of money just sitting in her account, she has $766, and I'm going to round that to 59 cents. So $766.59 will be sitting in her bank account after 12 years, and all it was doing was sitting there. So if you're willing to part with your money and let it sit somewhere for a while, you could make a little bit of money back. All right, let's try next problem here. Augustus rents a house for $700 per month, but the rent goes up 6.5% each year. After 5 years, how much will the rent be per month? So the first year that he's in that house, it is $700. The second year, it goes up 6.5%. So this is actually similar to the last problem in some ways. So what's the price going to be that second year? So again, it's $700 plus it's going to be an increase of 6.5%. So it's going to be 700 times 0.065. So here is the amount of money that it's staying, right? It's not going down. We're keeping the $700, but we're adding on 6.5% of that. But just like we saw in the last problem, both of these terms have a 700 I could factor out, and I get 1 plus 0.065. And this makes far more sense, right? Because this is just a faster way to get the answer. So it's the $700 times 1.065. The 1 is keeping the $700, and then the 6.5 is the extra percent that we're adding on. So again, go to your calculator. 700 times 1.065 is $745.50. So again, every year we're just going to multiply by another 1.065 because we're going to take the previous year, increase it by 6.5%. The previous year, increase it by 6.5%. So we're just going to continue in that format. So what does my formula look like? Well, the first year, he is making $700. Now, why is that different than the previous problem? Well, in the previous problem, we just put $570 in. That was how much we put on day one. But the first year was at the end of that year, right? How much money was in the account, and that's where I had to figure it out. But here, the entire first year, he's paying $700 a month. It's not until the second year that that increase occurs. So hopefully that makes sense. So it's 700 times, again, every year I'm going to multiply by 1.065. Hopefully you know where I got that number from, raised to the n minus 1. So after 5 years, how much money is he going to be paying in rent? Well, now all I got to do is plug in 5. So 700 times 1.065 raised to the 4. 5 minus 1 is 4. Grab my calculator and see if I can type this in right this time. 700 times 1.065 raised to the 4. And there we go. So it was almost a $200 increase, right? $900.53. So $900.53 is going to be his price of rent in 5 years. So maybe at that point he wants to start thinking of another house to rent because that's going to start to get pretty costly. All right, now we're going to look at another problem that's very similar, but it now becomes arithmetic because of a slight change. So again, make sure you're paying attention here. So Danielle rents an apartment for $500 a month. Okay, cool. But the rent goes up $110 per year. So the previous problem, the rent was going up by a percentage. This time it's going up by a flat fee. Every year it's going up $110. So the first year, she pays $500 in rent. The second year, it goes up to $610. The third year, it goes up to $720. The fourth year, it goes up to $830. So now this problem is not geometric, it's arithmetic because we're going up by the same amount each time. So my arithmetic formula is What was it the first year? $500. Plus, what's it going up by? 110 times n minus 1. That's it. Let me just clean this up. 500 plus 110n minus 110. And a sub n. 110n, 500 minus 110 is going to be 390. So that's my value there after I combine like terms. So there's a formula to find the price of the rent any given year. So what's it going to be in the 9th year? Well, it's going to be 110 times 9 plus $390. So let's see here. 110 times 9 plus $390 is $1,380. So her price of rent is going to skyrocket. So again, it actually makes more sense to have your rent increase by a percentage because at least it's a little bit over time. Whereas if you go up by $110 every year, that's a pretty steady amount. You're going to increase really, really quickly that way. So she's paying a lot of money that 9th year. So again, she might want to get a new apartment that year. All right, next problem. Jackie has a piggy bank that she saves money in. The first week, she puts $20 in the piggy bank and plans to add $15 each week after that. After 25 weeks, how much money is in her piggy bank? So once again, just kind of get the ball rolling, right? The first week, she put $20 in. So the first week, there's $20 in that account. And then every week after that, she's going to add $15. So the second week, there's now $35 in her piggy bank because she added that 15. After the third week, she put another 15 in there. So now she's at $50 in that piggy bank. So I'm going up by $15 each week, clearly arithmetic. The formula is how much money is in there the first week, there's $20 in there, plus the common difference is $15 extra each month times n minus 1. Cleaning that up, we get 20 plus 15n minus 15. So that's 15n plus 5 when I combine the 20 with the negative 5. So there's my formula to find how much money is in her piggy bank after any given number of weeks. So after 25 weeks, she has 15 times 25 plus 5. So let's see here, 15 times 25 plus 5 is $380. So if you guys at home are looking for a way to start saving some money, something as simple as put $20 in a piggy bank and every week promise you're going to put $15 in there. And after 25 weeks, and you got to wait a while, but you will save $380. Maybe if you want to buy that new shiny bicycle or that new, well, that'll get you about halfway to, or maybe even less than halfway to your new PlayStation 5. But anyway, there you go. All right, one more word problem for you guys, then I promise we'll be done. I don't want to bore you too much here. All right, so a bowl-shaped stadium has 50 seats in the first row. But a bowl-shaped stadium, as you go up, it gets wider. So as we go up, each row has 3 more seats than the row before it. Clearly arithmetic, right? We're adding 3 more seats to every row as we move forward. So that's going up 3, up 3, up 3. Definitely arithmetic. So there's 2 questions here. How many seats are in the 20th row? And if the stadium has 90 total rows, another typo, I'm full of typos. If the stadium has 90 total rows, how many total seats are in the stadium? All right, so first we got to figure out the 20th row, but why don't we find a formula to figure out how many seats are in any row? So essentially we got 50 seats in the first, then 53 in the second, then 56, and then 59. Pretty easy here. So the arithmetic formula is going to be 50 in the first row plus an increase of 3 times n minus 1. What an easy formula. Cleaning it up a little bit here is just a little bit of basic algebra. So here we go. Here is a formula, 3n plus 47, to determine how many seats are in any given row. So how many seats are in the 20th row? All I got to do is plug in 20 for the 20th row. And grab my calculator. 3 times 20 is 60 plus 47 is there's 107 seats in that 20th row. Now the stadium has 90 rows. How many total seats are in there? So I basically want to add up the first row, the second row, the third row, the fourth row, the fifth row, the sixth row. I want to keep adding all of these rows together. So the first row had 50, 53, 56, 59. So I definitely want to find the sum of my formula, 3n plus 47, starting with the first row going to the 90th row. So now this is a summation because I want to add up all of my rows of seats. But again, we know a formula for this. This is awesome. How easy. All I'm doing is creating that summation. The formula is 3n plus 47, first row to the 90th. So this is arithmetic. So my formula is taking the number of terms. 1 to 90 is 90 terms, 90 rows. The first row that I care about is the first row, which of course has 50 seats in it. Plug in 1. 3 times 1 is 3, plus 47 is 50. Plus the 90th row. How many seats are in that 90th row? I guess I got to figure that out real quick. In that 90th row, there's 3 times 90 plus 47. Again, I'm using the formula. 3 times 90 is 270 plus 47. There's 317 seats in that 90th row. Again, I'm just following the formula, guys. All divided by 2. All right, so I go to my calculator now. So I have 50 plus 317 divided by 2 times by 90. And the entire stadium holds 16,515 people. 16,515, well, let me say seats, because maybe not every seat is filled, so I can't say there's going to be that many people. But 16,515 total seats. So pretty easy, pretty cool, right? It was a problem that involved both a sequence to figure out how many are in the 20th row, so I had to figure out a formula to figure out what seats are in each row. And then I figured out how many total seats by using a summation, and that's where I just used my formula for an arithmetic summation. It worked out pretty quick. So pretty easy, guys. Hopefully you understand these, and now you're just going to get some good practice with these word problems, and you'll be good at them in no time. Just be careful. Some of them can be a little bit confusing, especially these money problems. So really take the time to say, okay, what's happening the first week? What's happening the first year, the first month, whatever it is in the particular problem, and then determine what that is and make sure you truly understand percentages. Hopefully you do. Hopefully you did even coming into this video, but some kids easily get confused with increasing of percentage. So you have to multiply, but it's easier to multiply by 1.025 for this problem to see that that's how you figure out your final amount. So hopefully that was easy, but again, some kids have to process that for a little bit to understand it. All right, love you guys. See you later.